In this video, we are going to solve example for inverse Laplace transform. So let us start with. So whenever it is asked to find out inverse Laplace transform, here x of s is given 6s plus 16 upon s square plus 5s plus 6. Now whenever you have such kind of equation, so first of all check the degree of numerator and denominator. So here we get the first case as if degree of polynomial in numerator is less than degree of polynomial in denominator, in that case go for partial fraction expansion. Partial fraction expansion. Secondly, if degree of numerator is greater than degree of denominator, then first go for division and represent your answer as quotient plus remainder upon divisor, where the degree of remainder polynomial will be less than the degree of divisor polynomial, and then apply partial fraction expansion. So in our case, the degree of numerator is less than degree of denominator, so straight away apply the partial fraction expansion. To apply partial fraction expansion, we must first find out the roots of denominator polynomial. So there are various ways to find out roots of denominator polynomial. So it is a quadratic polynomial, so numerator is as it is 6s plus 16 divided by, the simplest way to find out the roots of denominator polynomial is keep first term as it is plus, now split the second term which is 5s in such a way that the addition of this term should be 5 and the multiplication should be 6. So I will split 5s into two parts, where the addition and subtraction of those two terms will result into plus 5s and multiplication of those two coefficients will result into 6. So I can split it in this way, 3s plus 2s. So 3 plus 2 becomes 5s. So our original polynomial is as it is, and the coefficients 3 and 2. So 3 2s are 6. The third term is 6 in this way. Now 6s plus 16 divided by, so in from first two terms take s common, the remaining term is s plus 3. Similarly, from the last two terms take 2 common, the remaining term is s plus 3. So our equation becomes now s plus 3 can be taken common from both the terms. So s plus 3 and the remaining terms will be s plus 2. So we have obtained the roots of polynomial as s plus 3 and s plus 2. So now apply partial fraction expansion. So here the term 6s plus 16 divided by s plus 3 and s plus 2. Here we have two roots. So we have a and b with us, a upon let's say s plus 3 plus b upon s plus 2. Now cross multiply and simplify the terms. So here we have 6s plus 16 upon s plus 3, s plus 2, here a into s plus 2 plus b into s plus 3 and whole divided by s plus 3 into s plus 2. So here both sides we have same denominator, so denominators can be cancelled out and the simplified equation remains to be 6s plus 16 equal to a s plus 2 plus b into s plus 3. Now we are supposed to find out these coefficients. So to find a, now see what arrangement we have to do over here is we need to find out a. So we have the root associated with a is s plus 2 and the root associated with b is s plus 3. So we have to make the root of b as 0. So I need to substitute the value of s. So put s equal to in such a way that b becomes 0. So here s plus 3. So this to become b 0 we need to substitute s equal to minus 3. So minus 3 plus 3 becomes 0. Therefore we get 6 into minus 3 plus 16 equal to a into minus 3 plus 2. So it is 6 3s are 18. So minus 18 plus 16 equal to minus 3 plus 2 is minus 1, which is equal to minus a, and now a is our 2. So we have got the first value as 2. Similarly, we need to find out the next value b. So to find b, apply same logic. So put s equal to. So now to find out b, a should become 0. So look at the brackets of a. So it is s plus 2. So minus 2 plus 2 will be 0. So substitute s equal to minus 2. So we can simplify it further now. So 6 into minus 2 plus 16 equal to a into minus 2 plus 2 will become 0. So this term can be neglected, plus b into minus 2 plus 3. So it is 12 to minus 12 plus 16 equal to 3 minus 2 is 1 equal to b. So our b is equal to 4. So in this way we have obtained the coefficients a and b using partial fraction expansion. So let us substitute these values in the first equation where we have used the partial fraction expansion. So our x of s becomes, it is a upon s plus 3 plus b upon s plus 2. So a is 2 and b is 4. So 2 upon s plus 3 plus 4 upon s plus 2. This is our x of s. Using partial fraction we have got this expression. Now we need to find out inverse Laplace transform. So to get inverse we have e raised to minus 80 u of t has a Laplace transform of one upon s plus a with ROC sigma greater than minus a. So never forget ROC in case of Laplace, whether it is Laplace transform or inverse Laplace transform. Now if we apply this in above equation, so taking inverse Laplace transform on both sides, so we get, so x of s, its inverse will be x of t equal to this value 2 upon s plus 3. So 2 is the coefficient, so will be as it is, and 1 upon s plus 3 will become e raised to minus 3t u of t plus 4 into 1 upon s plus 2 will become e raised to minus 2t into u of t, and here the ROC will be, for first term it is sigma greater than minus 3 and for second term it is sigma greater than minus 2. So our final ROC, which is common region between these two, So sigma greater than -3 and sigma greater than -2. So ROC will be our sigma greater than -2. So this will complete our inverse Laplace transform. So see what we have done. X of s was given and we are supposed to find out its inverse Laplace. So from x of s, look at the equation and go for partial fraction expansion. But remember, here the degree of numerator should be less than degree of denominator. If it is not the case, if degree of numerator polynomial is greater than degree of denominator polynomial, greater than or equal to. So always remember this value, degree of numerator should be less than degree of denominator. Then and then go for directly partial fraction expansion. If degree of numerator is greater than or equal to degree of denominator, then use the division and represent your answer as quotient plus remainder by divisor. And then once you get remainder polynomial whose degree will be less than divisor polynomial, then apply partial fraction expansion. So here in our case it was simple numerical, so straight away we have applied partial fraction expansion. We have obtained the values of a and b, and then we have taken its inverse using the standard identity. E raised to minus at u of t results into Laplace transform of 1 upon s plus a, where ROC is sigma greater than -a.